Hey guys. Well, we've worked on a lot of algebra so far, and a lot of vocabulary and things like that. And what we're going to be moving on to now is something called proofs. And proofs are based on understanding and applying algebraic properties. We're going to be learning a lot of properties. Some you'll be familiar with, some might be new to you. And then we're going to be working on recognizing how these properties are used as we're simplifying expressions. So, first question we have to ask is, why are we learning this? And asking why is not a bad question, right? Why is an important question that has allowed us to make tons of advances in our world. We would still be stuck, with a stone wheel holding food over a fire if people didn't ask the question, why are we doing this? How can we do it better, right? So asking why is a good thing for most situations, right? I'm sure none of you were that little kid that drove your parents nuts asking them why. But why is an important question. And when we are working with our expressions, we should be asking, why can we do that? Why can we make that step? Why can we simplify that operation or those terms? And our reasons, our answers to that why question is our properties. So we're going to learn a bunch of properties today. You've got a chance to write them down in your notes. Please make sure you write them down and fill this all in so that you'll have a good reference to come back to. We're not expecting you to have them all memorized at the end of this video, but we are going to expect you to be familiar with them at the end of this video so that we can work with them, and eventually you'll have them down when it comes time for an assessment. So our first property is the multiplicative identity property. And what that says is if a value is multiplied by 1, the product is the same value. Our example is 8 times 1 is 8. We're multiplying, and it's identical to what we started with. 8 times 1 is 8. Now we have the multiplicative inverse property. If a value is multiplied by its inverse, also known as its reciprocal, then the product is 1. Notice in this property we're not multiplying by 1, we're multiplying to equal 1. So 2/3 times 3 over 2 is going to simplify to 1. The multiplicative property of 0 is one of our more simple properties that we use a lot. If you multiply any value by 0, the product is going to be 0, right? Zero product property. If the product of two values is 0, then at least one of the values must be 0. This is essentially saying it's impossible to multiply two numbers that are not 0 and get 0. Think about it. It's impossible. The additive identity property. Same deal as our multiplicative identity, except we're adding 0 to something to get the same exact value. In our additive inverse, if we add a value in its inverse, also known as its opposite, the sum is going to be 0. Negative 15 plus 15 is 0. Okay, so let's talk about another property here called the commutative property. Now, you might have heard the word commute if your parents have to travel a distance to get to work. And what commuting is essentially is trading places, going from one place to another. And what our commutative property says is the order we add or terms or multiply factors doesn't matter. So 2 plus 5 or 5 plus 2 gives us the same value. Negative 3 times 4 or 4 times negative 3 gives us the same value. This is not true with subtraction. We can see if we flip the order of subtraction, we get different values. Same deal with division. We flip the order, we get different values. So the commutative property is only for addition and multiplication. Our associative property says that the grouping symbols, where you put grouping symbols when you're adding or multiplying, doesn't matter. So we can see here, if I have 3 terms that I'm adding, it doesn't matter if I group 8 and 4 and add those first, or if I group 4 and 10 and add those first. I'll get 22 either way. Same deal with multiplication. Whether I group 7 times 2 and do that first, or 2 times negative 5 and do that first, I'll get negative 70 either way. Again, notice this is only with addition and multiplication. Subtraction and division are not part of the associative property. The values will change if we change the grouping symbols. So, now this brings us to some properties that you might be a little bit more familiar with. The distributive property. And this property says if a quantity is being multiplied by an expression in parentheses, and we say parentheses, but that could also be brackets, braces, those types of grouping symbols, then the quantity can be multiplied by each term of the expression. So let's look at an example. We have 7, our quantity, being multiplied by the parentheses there. So what the distributive property lets us do is to multiply 7 to each of those terms individually. So we'll 7 times 3x, 7 times 8y, 7 times negative 4, and we'll get 21x plus 56y minus 28. Our last property that we are going to look at is the substitution property. Now this is a property you're very familiar with if you play sports, such as soccer, right? I like watching the World Cup, not so much MLS, but I love watching Euro Leagues and all the Champions League, Premier Leagues and all that stuff. And if you're making a substitution in soccer, one person has to leave the field and another person has to take its place. Also, you're not going to substitute a forward for a goalie or for a midfielder for a defenseman, right? You're going to substitute somebody in the same exact position. So we say if two quantities are equal, then the quantities can replace each other in an expression. So we have this expression, 2x squared minus 7x plus 8. Now we remember from our previous lesson that none of these are like terms. So as this expression stands at the moment, nothing can be simplified. But if we know that x and 4 are equal to each other, in other words, they play the same position, we can substitute 4 for x. So x is going to leave the expression and 4 is going to come into the expression in its place. Now we can follow our order of operations gemma and simplify this expression. Right? We can see that we would end up with 12. Well, I know we've just thrown a lot at you here. So let's take a step back and let's practice using some of these properties. So what I want you to do is use the distributive property and what you know of like terms to simplify these expressions. So go ahead, pause the video, and give these 4 a shot. Ready? Pause. And let's check our answers. We should have gotten 36x minus 45, negative 3a plus 4b. Remember, our Ninja 1 is actually out there with that negative. We would have gotten 29g minus 63 after we distributed and combined like terms. And in number 4, we would have got 16d minus 16c minus 42. So that's some practice with the distributive property. What about our substitution property? Well, we have 2 expressions here that cannot be simplified as they stand, with a, b, and c as the variables. But we know what a, b, and c are. A is 6, b is 3, c is 2. So what we want you to do is substitute for a, b, and c, and then use order of operations, use gemma, to simplify each expression. So go ahead and pause the video now. Let's see, how'd you do? Did you get 13 for the first one and 20/3 for the second one? Hopefully you did. Again, guys, I know we're beating this horse, but it might be dead, but we're gonna keep beating it all year long with the videos. If you have any questions on these 6 examples here, please, please, please come ask in class. Now, let's talk about some of these other properties here. What you have in front of you is an expression that has been simplified. You don't have to do any work to simplify. What we want you to do is provide the evidence, provide the answer to the question why in using our properties. So look at the properties that you wrote down in the notes, and we want you to go through each of these 12 and decide which property was used to simplify the expression from the first line to the second line there. So go ahead, pause the video, and try these now. Well, let's see how you did. Take a look at those properties in green there. Take a look at the examples you have in your notes that we looked at together here. You'll see that they're pretty similar there. Again, last time I'm going to say it for this video, if you've got any questions on these 12 examples, if any of these properties just aren't making sense, you're just not sure how they relate to the expression that we have there, please, 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 guys, make sure you're asking questions in class. Circle it in your notes. Put a big question mark so you remember to ask. Well, that's pretty much how I imagine the end is going to be. And if you don't understand why a Mentos truck and a Coke truck could cause the end of the world, I encourage you to go get a bottle of Coke and a package of Mentos, go out in a field or a parking lot, and combine the two and see what happens. It'll be fun. Until next time, guys, see you later.